Okay, so hi all. I am Namita and I will be today's moderator, and I am a member of Team Shakti. And today we have a session of network traffic analysis, and our speaker is Sylvia Neria. She is a cybersecurity auditor at Siemens. She works for identifying security vulnerabilities in Siemens infrastructure products. And prior to that, she worked as a penetration tester for 2 years, mainly focusing on web and mobile applications. So, Sylvia, hi.
Hello, good afternoon. Thank you
Yeah,
very
good
much for
afternoon.
the introduction.
Yeah, sure. So you can start your session, I guess.
Okay, thank you.
Yeah.
So first, I wanted to say thank you to for everybody that is attending here, and also for the organization for working on ShaktiCon. I think that is a really great initiative, and I hope that today we learn like one or two things about traffic analysis. So I would like to make this training as interactive as possible. So we have some exercise for later, but also you have like any questions or things that you want to comment, please feel free to like raise your hand on Teams or like to like uh, just like come in and like say whatever you want. So as it was mentioned, I'm Silvia. I'm coming from Spain, but I'm currently working in Munich, in Germany. I'm working in Siemens. But in my background, what I did is that I studied computer science, and later I did a master's degree in cybersecurity. After that is when I started my professional career. Is when I worked like for 1 year and a half as a penetration tester. But also what I was doing there is in the same company, I was working on creating CTF challenges. So we were creating them for like cybersecurity congresses that were happening in Spain, and also one for the European League. There were different countries from the European Union were participating. So yeah, my background from like the CTF part is more like in preparing them rather than like playing them. But I think that they are like really cool. So what we are going to do today in this training is understand a bit how like our traffic looks within like the network. So like now first we need to understand like why do we monitor the traffic and for what like do we want to monitor it. So there are like let's say like the legal part and the illegal part. So it's legal to monitor the network for example, if you want to see like the performance of the network, if you want to do it like for like troubleshootings, like any problems or issues that it could happen, like to trace back what was the real problem and the connectivity. Also to perform like a protocol analysis, so for like investigation purposes, also like to work on them, and also for malware analysis, because with analyzing the traffic, we can like see where the malware was trying to connect, what kind of information is sending outside, and all of this. From the bad things that we can do, like for when monitoring the traffic, is that we can like spy on communications from other people, and also to perform non-authorized user profiling, which this means is like getting as much information of a user. So um, what kind of applications is using, what kind of web pages this person is browsing, so you can like learn a lot of the interest that this person has, and also for retrieving sensitive information that was sent unencrypted. There are still a lot of services out there that are unencrypted, and the problem with this is that everything is sent like plain text, which will include like everything, like usernames, passwords, also like bank accounts. and like, I don't know, private keys. So it's really something to take into account. So what kind of information can we get from traffic analysis? So as I mentioned, we can learn like what applications are being used, what versions, because this is something that is sent over the data on the packets. Also like what services are used. Okay, just give me one moment. I think that can you see my screen? All the people that is here, because I see the comment that
Yeah, we can see your screen.
yeah,
Yeah.
It
I
might
can
be
see.
some network issue or something. It's
Okay,
fine.
I can't see the screen. Should I do something?
No, it's fine. You can continue.
If you cannot see the screen, maybe you can go out and come back again. I don't know.
Yeah, it might be their network issue. It's fine.
Okay, so go out and come back in?
Yeah.
Okay, great. Thank you.
Yeah, so something that we can also like get from the packets is, for example, the locations. Some services, for example, we are on the mobile, has the location activated, and this is also something that is sent over our like traffic. And also like files that are being exchanged as well. And if we are like playing in like CTFs, then we will also like find flags. So before analyzing anything, we need to understand like how data is transmitted over the network. And the thing is that any data that is like unencrypted, as I mentioned, would be vulnerable to what is called sniffing, so to be retrieved. So imagine that you are visiting an HTTP web application, and that site requires authentication. So you need to like, to put your username, your email, and your password. Then everything that you introduce there, because it's something that is not encrypted, will be like transmitted like plain text, and you will be able to see this. So as you can see here, I have like I made this really nice table where you can see some of the most popular protocols that are used nowadays for our normal communications. And you can see which of them are encrypted and which of them are not. So for example, HTTP and HTTPS are used for web applications. The difference between them is that, I mean, they use like different ports, but HTTPS is the secure one where the traffic is sent encrypted. Then we have SSH and Telnet. Then these two protocols are used in order to access machines remotely. So you can connect remotely to the terminal of the machines and work like if you were like directly there. The difference between them is that SSH is encrypted and Telnet is not encrypted. So yeah, as I mentioned, like you can also like see everything, all the commands that the person that is working there is typing. Then what else we have here? FTP is for uploading and downloading files, so for a file transfer. And then we have also like the secure option, which is SFTP. Also the same with DNS, and then we also have like POP3, SMTP, and IMAP, which are like for email communication. But at the end, I mean, these original they were unencrypted, and over time they they build the secure layer on top. So now they have like the port where they can like use the encrypted mode. But the thing is that it's always better to use the encrypted one and to avoid the encrypted protocols. And the best way to do it is just like disabling the protocols that are not encrypted. So you avoid like having like any misuse of them. So what tools can we use for performing like network traffic analysis? We have like several of them. There is more than the ones that I put here, but I just wanted to mention the ones that are like more common. So we have TCP Dump, Packet Total, Network Mining, Wireshark, and then there is more. But the thing is that, for example, the first 4 ones are for free, and then there are more that are like also like you will need to pay, like Packet Miner. So that's what I also, it didn't make sense for me to mention them. So first, I'm going to explain a bit like of information on about like these tools, and then we are going to go in deep on one of them, and we are going to use that for the analysis of some traffic. So first, TCP dump, which is known to be like, let's say, the original packet sniffer and analyzer. It was launched in the late 80s, I think. I don't remember exactly. But what it does is like it captures the traffic on the specific network interface that you select, and it dumps the result directly on your screen. Okay, so it's a command line tool. So it's like on the terminal, and it's let's say a bit difficult to use because yeah, when you don't have like a graphical interface and you have like a lot of data, things can get a bit let's say messy. Also, the problem with this is that it cannot read the traffic, so the pickup files that it captures, it can only like show them, but then you will need like additional tools and commands to analyze them. So yeah, I'll say that is difficult depending on what you want to do, but for troubleshooting problems on the network, this is a tool that is commonly used. Then Packet Total, this is a free online tool for analyzing packets that are like captured. So it's similar to, I don't know if you know, like Virus Total. So you drop there like your pickup file and it will analyze it. It uses several, like as I mentioned, they're like open source technologies. So VRO for like IDS for identifying like the protocols and extracting the data from there. Suricata for identifying like any malicious activities that is happening on the network, and Elasticsearch for extracting the metadata from the packets. But something important to take into account when using a Packet Total is that because this is an online tool, as soon as you put your packet there and it starts being analyzed, it's already on the internet. So this is something that, for example, if you're like starting to like doing traffic analysis and you just like take a pickup file from the internet, then it's fine to put it there. But this is not where you should put something that you might think that could have like confidential information, because this is going to end up on the internet. But yes, as I mentioned, the good thing is that you don't need to have like anything on your computer. This is everything online, and it also gives you some statistics that is like really graphical and easy to see if you're like starting in this journey. Then the third tool would be a network miner that can be used also as a packet capturing and analyzing tool for pickup files. The great thing about this tool is that it automatically extracts all the files from the capture that you have. But the thing is that it doesn't have it doesn't give you the capabilities or the features to analyzing the packets manually, and it does not support all the protocols that are like out there and yeah available. But you can see here how it looks. So as I mentioned, it will like retrieve all the images and all the files that are sent over the network on the pickup file that you provide. It will also show in another section all the credentials that that were shared and that this tool was able like to retrieve because maybe they were like unencrypted. So it's also like easy if you're starting the journey. But now we're going to go in deep on Wireshark. Wireshark, I would say that is the more complete tool. It gives you a lot of freedom to analyze the packet, and because it has like a graphical interface, it's not like TCP dump, so it's easier to work with. It's true that also it has like a lot of like features, so the learning curve for Wireshark can be a bit deep, but it gives you a lot of like flexibility. You can capture data from like different like network interfaces. It also like support a lot of protocols. You can like if you have let's say the keys, you can also unencrypt some of the traffic. You have like tons of filters that we are going to see some later. You can also extract the objects. So it is not like a network miner that it automatically extracts everything and it show everything to you in a more like graphical way. Here maybe you need to work a bit on that, but at the end it gives you more support in other parts. And this is really how it looks like. So it can be like for the first time, as this got like a bit like messy, like this is like a lot of information and I don't understand anything, because it also like gives you the details of the packets. It also gives you the X dump, and yeah, but also like the good thing here is like, you know, like when you're like when traffics are being sent on the network, there are like a lot of communications, so everything gets, let's say, a bit messy. So they are not like when you're sending a message, the packet is not like straight like following like the same line. But here with Wireshark, what you can do is like follow streams of packets. So this tool will show you exactly all the packets that are belonging to a communication. And so that is really good for analyzing. And I'm going to go now a bit into like the features that Wireshark has, because we are going to focus now on Wireshark, and that's what I'm going to use later to analyze some of the files. But I don't know if you have any questions until this point, or you want to mention any other tool that you know from the ones that I already mentioned. Okay, so one of the big features that Wireshark has is the filters. So you can filter like for every protocol that you want. You can specify the port, but you can also, for example, for HTTP, you can just put HTTP and it will like automatically filter all the traffic and just show you the HTTP one. So like the same for all the protocols. The thing is that you can also like exclude some of the protocols. So you can just like, you know, with exclamation mark, this will like exclude the protocol that you put, because sometimes, for example, the DNS like gives you like tons of traffic that maybe is, you know, like let's say like a bit trash for your analyzing activity. So you can take that out. You can also like filter for the user agent on the HTTP. So this is, for example, used for the user profiling. Because you can see like what kind of device this person is using. If it's an Android, what kind of Android it is. So you can also see if there's like any vulnerabilities there. And you can also filter to see if there's like any location being exchanged on the packet. So for example, this would be the filter. So this is something that you can like put on Wireshark, and it will just send you like all the packets that contain this. But there are like tons of more filters. But I mean, Wireshark is like incredibly huge, but it has like also really good documentation. So you can just go like on the Wireshark webpage and yeah, look there like for whatever like protocol maybe you are like focusing, see what kind of like filters do they have. So some of the features that Wireshark give us is that we can see the endpoints, so the systems that are there on the packet dump that we are analyzing. So you can see that we can go to statistics. It has like a lot of features, but on endpoints, you are able to see like the different IP address and also the number of packets that they are like sending. So the thing is that maybe you want to focus on the one that is like sending more packages, because it could be that in that communication, there's more possibilities that interesting information is being exchanged, but this is something that you will be able to like to filter later. Also conversation, and this will allow us to see which IP addresses are communicating with which IP addresses. So it's not that you will see like just like, okay, this is sending like 100 packages. Like with this, you will be able to see like how many packages they are being like exchanged between A and B, and also from B and A. So you can see like if there is like a yeah, something going on there. If there's like one IP address that is sending like ton of messages like to everybody, then that might be some kind of maybe like an attack. Yeah. Also some filters that we can use, and this is really interesting, I would say, like also like for CTF, is that we can filter to find a specific string inside the packets. So for example, we can go to find packet and then specify where we want the string to be like look into. So in the packet details or in the packet bytes or in the data. And we can, for example, here I was like trying to find like passwords, but if you're like in a CTF, maybe you can try to look for the word like flag, or if you know that the flag of that like CTF has like a specific format to try to search for that format, or if you're like just searching for some kind of like I don't know, information that you may think that is out there, you can also just like yeah, try to find this here. It doesn't work always, but I think that is also like really useful, and is one of the first things that I normally try. Also, something that I mentioned is that before is that Wireshark allows you to follow the TCP. I mean the packet streams. So depending on the traffic that you are analyzing, if it's like an HTTP traffic, you can instead of like seeing all these packets like mixed together, you can just follow that stream, and it will show you exactly the whole like a stream of information that was exchanged in a more like organized way, so you can just like focus on a specific data and communications. So here, for example, it was like the case of like an HTTP communication that we were requesting a web page, then we got like some information back, we were sending like a post request, and this is something that we are going to see right now, because we're going to do, let's say, the first exercise. But before analyzing any packet that I will like give you, we are going to monitor our own traffic. Okay, so I'm going to, oops, here, copy this. Okay, this is like an online web application with a with a login that is not going on an encrypted way, because it's not using HTTP, so it's going like everything unencrypted. So if you go there and you type your credentials, you would be able to later see the credentials on the Wireshark. Okay, but I'm going to open my Wireshark now. I think that you can see it. So for example, I'm connected via Wi-Fi. So for like capturing your own traffic, you need to like select the interface that you're using. Maybe you are like connected via like an Ethernet cable, but in my case, like for the one saying that the Wireshark is in a VM, I don't think it will matter if you are like using also like the browser from the VM. So now I'm starting to monitor my traffic. Okay, so this is the web applications that I just sent you. So now here, what I mentioned, that is not secure because it's not using like the encryption layer. So now, for example, if I put here my name and then a password and click OK, I mean, this is not going to work because, yeah, it's just for test. But now you can like stop the traffic. Okay, and we have like everything that was like being captured and sent with. I mean, we have all this like UDP traffic because of the in the call that we are now. So what I'm going to do is just like, for example, I will filter and take out like all the UDP packets. So now we have like a more clear stream of messages, but to be like more, let's say, granular, we can add more filters. And the thing is that we were connecting to an HTTP application, so we can also like filter and just show us the HTTP traffic. So let's say that we just want to see like the HTTP protocol. Okay, so we see, okay, I mean, I only browse that page. So you can see here that there's like a post request that is like where the normally where the credentials or the any parameters that you send are sent. So if we follow the stream, okay, we see the whole stream of packages, and then you can see the username and the password that you have introduced. Okay, and but this will work not just with this page, but with every HTTP page that you are like browsing. And the thing is that there's still out there some web applications that are not using HTTPS, and if there is like someone monitoring the network, then he will be able to see like the credentials that you introduce. I mean, not only the credentials, but everything that you are like sending to this web page. So I don't know if you were able to try this. The thing is that this challenge is not yet in that platform because it's just like something like for you to monitor your own traffic. But I don't know if someone can let me know if you can see my screen properly, because I saw these messages that they say that it's jumping up and down. I don't know if it's because of the Wireshark setup. Okay, good. So yeah. I think that for some people it is looking good. I don't know if you were able to try that on your laptops or on your computers. Maybe you can like drop me a message like, hey, yeah, I try and I can see that. Yeah, sure. So I mean, I'm going to like do everything again. So first I'm going to start like capturing the traffic. I'm just going to close this. Okay, so I'm back on the initial Wireshark like a homepage, let's say. So I will start like capturing my traffic. I'm using like Wi-Fi, so that's what I'm like capturing right now. Okay, I will take out this filter. It is getting all these packets like UDP because of the Teams meeting that we are having now that is going through that protocol. And what I'm doing now is that the link that I send you on the Teams chat, I'm going to share that again just in case it got lost on the conversation. Okay, but this is an HTTP login, so it does not go encrypted. So everything that you enter here we will be able to retrieve that on the Wireshark like traffic dump. So for example, if I put my name here and I put like a password, let me just say. Okay, so now this has been like sent there. Let's say like I want to send something more. Okay, now we can stop to monitoring the traffic, and we can filter because we already knew what we were using. That was like an HTTP page. We can just filter for that protocol. Okay, but this is the case because we know what we are looking for. Okay. So we just like put here, I mean, we can also like put the filter for the port 80, which is the one that HTTP is using. But at the end, this is like easier. So we just put it there here in this line. Let me see if I can like make it bigger. Okay, so we now see everything that was exchanged. Okay, so in this first packet in the get, we are requesting that. I mean, this is like how the HTTP communication work. First, we are like asking for the web application, like, hey, give me the web application. I mean, the web page. Now with this, okay, we get the application, and now with the post is where we are sending our credentials. So if we right click on this and then follow HTTP stream, we are going to enable just the stream of packets from that communication. Okay, and here we can see them. So this is the first thing that we send, the red one. That's what we requested. Like we requested, like, hey, send me the web application, the web page. We got the code for the web application, so we're able like to see it. And after that, in this post, I don't know if I can make this bigger. Yeah. In this post is where we were like sending the information. Okay, so it's down here in this uname and pass, where you can see everything that I enter. Okay, if this was done with HTTPS, this is something that you will not be able to see. Okay. So the problem here is that if you are, for example, connected to a public Wi-Fi and there is like someone like monitoring everything that you enter here, it doesn't matter if it's like username, password, or like if it's a file that you are sharing, like whatever thing that you are doing on an unencrypted protocol would be able like to be like visible. So I think that now maybe it's more clear how, let's say, like the first like exercise of Wireshark like work. So I don't know if someone can tell me like, yeah, it worked for me. If you tried Bridget, I think that yeah, you got it. Okay, good. I think that now we can move then to the next one. But for example, I want to like explain a bit. This is the details of the packets as well. So for example, in the post is where I said that I was like sending the credentials. So you can also see it here on the details of the packets. Okay. But it's true that if you just follow that, you will see like the whole information of the whole communication. So now I'm going back to this. So yeah, this is, I mean, I'm going to share the slides later. I mean, I think that the Shakti team is going to share them. So I also like put here what we were looking for and how it would look. What else we can do apart like from like applying like filters is that we can also extract objects from the communication. So what kind of objects are there? They're like everything. The code, for example, that we retrieve from the web application is also something that we can extract. We can extract like images that are being sent. We can extract other files. If there's like any keys that are sent there, unencrypted, we will also be able to retrieve that. And yeah, this is something that we will like see later, but you can see here, like for example, in this communication example, there's like a lot of information exchange, but there's like also like some images. So for example, when you're like entering in a web application and there's like images there, that is like also something that the traffic will get, let's say, and an object that you will be able to retrieve, so to export and yeah, analyze later. So you just can like save everything on your computer, or you can just like select one. I mean, the one that is like interesting for you, and yeah, and work on that. Also, something that Wireshark can do is to decrypt the communications. So we can go to edit preference protocols, and we have here like all the protocols. And I mean, depending on the protocol that we are using, we can like enter like whatever is needed to decrypt it. Sometimes it's the master key or just like a passphrase. So if we introduce that and it works, like all the traffic belonging to that will be decrypted. But the thing is like how you get the decryption like key or information. It depends on like what you are working with. There is one exercise later where we are going to see that and also to try. But this is also something that is common for. I mean, it's like on the everyday life, but also from some CTFs. Like the main point here is that you need to get like this key to later decrypt the traffic where the flag is. So now is where we are going to play with some pickup files. So the pickup files are on the I don't know if I'm going to pronounce it properly, on the Tradova platform. I don't know if someone from the Shakticon team can share with us the link. If not, here on the chat.
Yes, we have shared in the chat. Yeah, we have sent it once more.
Oh, thank you. Oh. So now what we're going to do is just go through some challenges that I uploaded there. Let me see. Okay, so it will be in this section. So if you go to the link that it was provided and you follow like here the forensics, we are going to start with the beginner one, and then we are going to let's say go a bit more difficult, but it's just like a beginner level. So everything is going to be fine. So for the first one, if you click here, you will then download the file. I will not download it because I already have it on my computer. So what I'm going to do now is put it here on the Wireshark, so you can see how I do it. But the idea is that you do it also at the same time. If there is someone that is following the exercise, if you can tell me like, hey, I already got the pickup, I'm ready to start. Going to wait a bit because I understand that maybe you need to open a Wireshark if you didn't like for the previous exercise, and also for like going inside a Traboda and downloading the pickup file. Which exercise? So once you go into the link, let me just show you again. In the meantime, if you don't have like the Tradov account, Trabot account, you can make it. So once you enter, you can go to challenges. And the one for the this exercise are on the forensic. So if you go on forensics, these are the exercises that we are going to do. So we are going to start with the beginner one, and then we are going to be going up on levels. Okay. So the first one, if you enter, you can download this pickup file. That is the one that you need to open on Wireshark. Okay. Okay, so you can just like take your file like this and like drop it, or you can just like go to file, open. Yeah, that is a good point. If you're like doing along the steps with me, just like raise your hands here on the Teams. There is this icon on top where you can like press, so I know that if I can like follow, or if there's like something that was not understood properly. Okay, I don't see any hands. Is everybody following me? Was Wireshark a bit too much? I don't know, maybe you already knew Wireshark. Which is our first challenge. The first one is going to be Shark on Wire. I'm going to put it here, which is the beginner one. So we are going to start in the beginner level, and then we are going to go up a bit, because yeah, let's say that the levels are like this is like something that with what I already like explained you will be able to solve. Then for the second one, maybe you need like some help from other tools. It may be that you don't have like the other tools, but I will just like also like share that here on the slides. It is not there. Let me see if I can just like send you the link of that specific challenge. Okay. I send the link here on the chat. So I think that you should be. Yeah, I think that here you will see like all challenges that were uploaded, but for like all, let's say everything. But still, you can see here this one. So I don't know really, because I'm already like logging. So
This is the wrong link. Like you have to go back to Traboda trainings. You are under the main database right now. So the one link. This is the right link. I'll put the link again.
I'm going to share again the link. Ah, yeah, we will share it. Yeah.
Also, for those who just registered and just logged into the Traboda account, you'll have to join the contest before accessing the challenges. Make sure you join the contest.
Maybe you can explain like how they have to join the contest, because I don't remember like how I did it, so I cannot help from that side.
Yeah, as you log in, you'll have this button that says join contest. You click on that and you complete your registration process, and then you can automatically join the contest. Like there is one step to accept the terms and conditions, and then you log into the contest. That's it.
Mm. Hmm. Let me see if there is like someone already from the call that is able to see and to get this file, because I don't want to start like if you're not able to like follow me at the same time. Okay, I see that there are some people that already like Polly, you already got it, so I guess that you are already like on the web page, and you can see the challenges. And I see also someone who has the hands raised, Ini. I don't know if you have like any questions, or if it's because you are like following everything all right.
Yeah, just not finding the challenge. It says when you click the link, it just says challenge is not found. So I'm trying to join.
Yeah,
Okay, maybe
you would have to go to the link and then click join contest. I'll put the link again to the platform, and you'd have to click join contest in order to view the challenges.
Okay, someone already got the flag, but it's from the Shakti team. That's not valid. Okay, so I will just give some minutes, but before that, I just want to explain that these pickups is like not something that I let's say like capture myself. So for example, this first one is one of the challenges that were on the Shakti CTF that was performed in December. I think it was at the beginning of December. So we are going to solve this one, then we are going to solve the other one from other like CTFs, and so it's like a bit like of everywhere. Mm. Also, the thing of having the files here is that I mean, you can download it, you can like find the flag, and then you can enter the flag here on submit flag, and if the flag is correct, then I don't know, you will get like points, or like you will get this exercise completed. I mean, here, because it's like super easy, it was just like find the flag, but in the others we would have like a short description, maybe giving you some hints of what we are looking for. So, okay, let me see. I think that already like some people got access to this to the file, so you can already like open it on Wireshark. But Ini, you already got access to it, right? And
Yes.
that is good. Someone else is having like more troubles. If not, I will just start resolving it. But if someone else is having troubles, maybe you can like tell me now. So Lucy, you have your hand raised. Is that is fine or not fine? I'm a bit lost now with the hands.
Thank you. I joined the contest.
I didn't understand you. I don't know if you said something. Okay. Okay, that you managed to get into the contest. And I think that once you are inside that, if you go to the forensic, okay, if you are joining the contest, I think that if you go now to the link, you are going to be able to get it. Okay, you know what I'm going to do? Let's see if I can like just share the document here on the chat. I don't know. Oh my God. God, I don't know. It doesn't allow me to. Oh yeah. Okay. You're going to get first challenge here on the chat, so you can download it. I'm going to send also the next one, just in case in the meantime you cannot also like join, at least you have it. But the idea is that also like for the next training, if you want to participate also in the next one, the files and challenges will also like be there. Okay, Gabby, you are like already there. Let me just put this second challenge and I'm going to start. That is good. So now, once you have like this open, okay, what we need to do. The thing is that, for example, in this case, as I mentioned, this was a challenge that was made for the Shakti CTF, and the flag format was a specific one that I will show you just here. Shakti. Okay. So I think that you can see my notepad. Okay. So for the Shakti CTF, the flags were like this. Shakti, okay, and then the flag inside here. Because this was like an easy one, as I mentioned, the first things that we can try is just like filter by strings. So what we can do is just like take this Shakti, okay, which was the format of the flag of this CTF, and just go to edit, find packet, and then here, okay, it's already there, Shakti, okay, and we are going to search on the packet bytes. And once we click find, it will like try to see if there is like something here on the DAM that contains that string. Okay, it has found one. I don't know exactly where this is pointing. I think that's to the first one. Okay, so I mean, we see like the packet if we double click. So what we are going to do is follow the stream now. And we get the message. So the flag should be this one, the Shakti CTF Warsha is just awesome. Polly, if you copy this flag, I think that it should work, but I'm not sure. Maybe someone from the organization can tell us. I will copy also, so we can see if it's working. Yeah, I mean, that is the flag, Polly, you found it, but yeah, I think that maybe there's like some problem on the Traboda because it's also like not working for me. But I think that more or less you got the idea. This is, as I mentioned, like some of the like basic stuff that we can do. We can just like filter for like a specific string. For example, we could just also like filter for password in case we were trying to look for some kind of like other information, and then follow the stream. Okay, Gabby, I'm going to repeat. So you go to edit. Let me just clean this. So you go to edit, find packet, and then you get this line, okay? And here, because we were like playing the Shakti CTF, we knew that the Shakti CTF flag had this format, Shakti CTF, okay? So what I did and what you can do is just write here Shakti and look here on the packet bytes, the string value, and then click find. And then Wireshark is going to select what pack, if there's like any packet containing that string. Okay. So you select, and it went to the 35. Okay. So we now right click and then make follow TCP stream. You are able to see like the communication that contains that string. That contains also the flag. That is the one that Polly shared with us here on the link. I mean, on the chat. Okay, you got it, Gabby. That is really good. So that was the easy one. Just to get like comfortable with some of the things on Wireshark. Now we are going to move to the second one. Okay, I already shared the document. Is this one called raggedcom.pickup? Is here on the chat in case you cannot access the Traboda, but also here you can see like how it was solved. And now we're going to move to the second one, okay? That if you can access it, is going to be this one, okay? So what does it say here on the description is the following dump shows the failed attempts of gaining access to a determined telnet service. Can you help me find the password? So as I don't know if you remember from the beginning of the training that we mentioned that telnet was a service that was unencrypted. Okay, so we are going to be able to see the communications. So the thing is that we need to find the password that is working. Okay, and once we find the password, the flag has this format flag, and then this like keys and the password that we found. Okay, so let me open just I will close this one and I will open the next file. Okay. So this is what you will see when you are like opening the pickup file for the RuggedCom challenge. So we see a lot of telnet, a lot. So we want to find the password. This is unencrypted. So if we just try to follow the stream of packages, maybe we are able to see something. Okay. So the blue part, okay, now that we are following the stream, the blue part is the things that got sent to us from the server, and the red parts are the ones that we sent. Okay, so for username, we try admin, and we tried this password, okay, the red part. And then what we got again is the login page. We try this other username with this other password. And we got again the login request. And this is everything that you will see on this pickup file, okay? So I don't know if you're like following right now, but if you are like always like getting back the login form, let's say, what is the problem there? That is that you are not logging any of the times because you are not entering, like, let's say, a valid username or password, okay? So this is something that maybe we will need to work a bit more. But yeah, we see that he's trying with admin, with t.admin 12345 admin factory, and it's not working. Okay, what is this service? So we are trying to connect to a rugged operating system, to RuggedCom. Okay. If this is like the first time that you are seeing this, maybe you don't know what it is. So let's take a look on the internet. And this is something that we do a lot in cybersecurity. We look a lot on the internet. So let's say that I'm trying to find like RuggedCom, the RuggedCom Telnet password, because we are trying to connect via Telnet. Okay, so let's see if there is like any default password that this person that was that we got the traffic from didn't try. So the thing is that we see here that apparently RuggedCom is vulnerable because you can generate the password. So let's read, like, this module will calculate the password for the hard-coded hidden username factory. Okay, the thing is that this guy from the traffic dump, he was trying the user factory, but it was also one of the one that didn't work. And the thing is that the password is dynamically generated based on the device's MAC address. Okay, so let's see again, like the packet, what information was there. So this was like the login attempts that we were able to retrieve because they were like on clear test. We saw that it was trying like admin, and down here he was also trying factory, and apparently factory has like a default password that we can generate based on the MAC address. So what is the MAC address of this device? The thing is that that information is also sent on the Telnet communication. So if you read here, we can see the system name, the location, the product, and the MAC address. Okay. So now we need to find, let's say, a script or somehow how we can get to generate this password because we have the MAC address, so we will be able to retrieve that. So the thing is that I don't know if you're like familiar with. Let me see. I think I put it in here. We can find a script that is generating this on ExploitDB. That is a exploit database. You can find a lot of exploits there. And in this case, this one is there. It explains you a bit like what's RuggedCom, what was the problem there, that it has like if the account factory is not disabled, then and the password is not changed, which is like normally the case, that these things are not being like securely configured, you are able to retrieve the original password. So the thing now is that you will need to get this small code. Is a Perl code. So I'm going to do it for you, but because I have Kali open, which is where I normally. Okay. I think I copied here already the code. Okay, so this is the code that we found on the web. As you can see, I mean, I just like copied to my machine on a script, and that is the thing that we are going to execute. So the thing is that we try to execute now the code, like just as it was on the exploited database. What is here? Unexpected. Oh, okay. I was executing it wrong. My fault. But we see that it's telling us like how to use it. Like you need to execute that, but you also need to provide the MAC address because that's what this script needs to get the to generate the password. So let's go again to this and take the MAC address. So if you just like copy the MAC address and then go here and put it as a parameter, okay? Wait, I deleted the last letter. So you can see I'm just like putting the, I don't know if maybe I can, oops, give me one moment. Okay, so this is the password that it got generated. So this would be like the password that this guy should have like try entering on the login to really get access, because these were all like fail attempts. He never got like any response from the server like, hey, yeah, you are like already in. He was like all the time like requesting the password. And now if you want to try that, I don't know if this flag is going to work on Tradova. Let's see. So as it says here, the format of the flag is just like flag, and then you put here the password that we generated, because this was, okay, I think that the flags are not working because they also didn't work at the beginning, but I don't know if you were able to follow me on this one. This one was a bit more difficult because it's something that you need to find the telnet communication. You need to understand that all the login attempts were fail attempts, and then it's like wait. Okay, and then so you need to understand that those are like fail attempts, and like then search a bit on the internet what is this service for, then understand whose MAC address were those. This is the MAC address of this RuggedCon server. So if you take a look here. Yeah. Tracy told you, like from Mark Hamill. We don't know who that person is, but that is the information that the service is like telling us when we are like saying like, hey, I want to connect. He's giving us that information. Oh, you can see like really bad. Star Wars. Yeah, I'm not really fan of Star Wars, so I didn't know. But yeah. So this is the exercise. I hope you kind of follow. As I mentioned here, on the slides, I put the link to the specific exploit that I use. Okay, and the thing is that this service was vulnerable because it had the default password, and default password is something that even though sometimes it's incredible to believe, it's like really, let's say, some hanging fruits that you can find out there. So we completed our second exercise. If someone has like some questions about this exercise, please tell me now. If not, we are going to move into this next one that is a bit more difficult. Okay, apparently it worked for someone. So that is good. For Sandra, I hope that I pronounced your name well. So yeah, if someone is like also trying that. Okay. Okay, I see that also for more people work, so that is good. So then I also get that you're like following and understanding the exercise, which is really good. And now we're going to go to the next exercise. So do you need for me to send this file also on the chat, or you have like the access to the platform already? As I see, if someone needs the file, just like text it on the chat, and I will like share it here also. But I don't think that right now maybe it's necessary. So before starting just like the exercise and going there, you can like download it, open on Wireshark. I want to explain a bit what is the SMB. So this is like what is called a server message block, which is like a file sharing protocol for Windows. SMB2 is like, you know, the advanced version of SMB, but currently there's also like SMB3. And yeah, I mean, it's like for file sharing. And the thing is that for this, you need to authenticate yourself. So it supports multiple mechanism, authentication mechanism. So the main ones are Kerberos and NTLM SSP. Okay. So the thing is that where we are going to find here, I already told you, is the, I mean, I'm telling you now, is the NTLM SSP. Okay, so I'm going to open the Wireshark, and then we can like come back here to see. But for example, we have like some filters that could be useful, which is the SMB2, just to see like those packages. And we can also like just filter for like NTLM SSP, because that is like the authentication mechanism. And we are going to try to identify the handshake packets that, as you see on the image on the right, how this protocol works is that you're going to first like send a message like negotiating, then you're going to get like a challenge, and then is when you are going to authenticate. So what we need to do is get all that information, okay, from a specific user, because what we need to do in this challenge is also like to retrieve the password, okay. And the thing is that we are going to get the hash, and after that we are going to we need to crack the hash. So we are going to use another tool, but I'm going to open it now so we can like see it here. Okay, as I mentioned, we have like this pickup file. So I mean, let me open just here so I can also like show you the description, because if not, it's like you can be like a bit lost, like thinking what we are looking for. Okay, so here the description is like, during a red team exercise, the team has captured the following traffic. Can you help us identify the password for Joseph? Okay, and the format is like the same as before, flag, and then in the middle the password. Okay, so we know that there is like some Joseph username there. Okay, so because we need to use that, and I mean to find that the password for that specific user, and we already know that for the authentication they are using the NTLM SSP authentication mechanism. We are going to filter for that. Okay, so now we filter. We have like less packages, so it looks beautiful. Okay, and we can see here some of the messages that were exchanged. Okay, so we can see, for example, Joseph, that is the one that we're looking for, but we can see that also there was an authentication coming from the administrator, coming from Barak several times, also from Joseph again. Okay, so let me just show you again the slides to understand. I don't know how to put this to not cover the whole screen. Okay. So we see that there are like several packages because that is like the ones that we need to use. So for the authentication package, so the last one is where we are sending the username, but we need to get also like the challenge to get like the complete hash and then being able to crack it. So the thing is that normally in this authentication, the packet that is just like right before the one with the username is going to have that challenge. So if we have here the username, then here we are going to have the challenge thing that we need. Let me see. Windows plus R will put Windows side by side. Ah, okay. Thank you, Tracy. But I was just like, yeah, messing it a bit up. But now what I'm going to do is open this and start like getting the information from the information that we need. So we are going to get the, okay, let me just, I don't know how to do this without messing it too much. Okay, let's see. We need to get this information: the username, the domain, the server challenge, the proof string, and then the NTLM response. Okay, so the challenge, well, let's start taking the username. Okay, so we wanted to get the Joseph one, so we are going to let's say analyze this packet. So we double click, and we're going to now go in deep into this packet. We're going to start opening everything up. And in this security blob is where the information is stored inside the packet. So if you start like opening everything, here you have the information. So you get the username. So you are going to, I mean, you can just like type it, or you can copy printable text in this one and you put it. And then you need these double dots. Then the domain. Here, I mean the host name. And we, okay, printable text, and we copied. Now the server challenge. This was something that it was coming from the server part. So we need to go to the other packet. So because we are analyzing this is where the challenge, okay, it says here like the challenge is shared with us. So now we need to find the challenge. So if you go down, NTLM server challenge. Okay, this number. Okay, so you copy it as a hexadecimal stream. We are building our hash to crack. Now the proof string and the NTLM response is also something that was shared on the same packet as the username. So if we continue where we left it here, we can see the name, we can see the host name, and let me just, here we have the NTLM response. That is, and this is the information that we need, okay? The NTLM response and the proof string, okay? The thing, if you just take a look a bit closely, is that the response is beginning with the same string as the proof string, okay? So the characters are the same until here, okay? So we are going to copy this. We need to separate the proof string from the NTLM response. So the proof string was until this F88, so until here, and that is where we are going to make the separation. Okay, and now we have all the information that we need to use for cracking the password of this guy. So going back to Kali, is everybody like following me more or less? we got the information from the packets, and now we're going to use a Hashcat to decrypt it. The thing is that I'm going to, let me just remove this because I was mixing some. Okay, I'm going to create a file that, where I'm going to put the thing that we want to crack. So I'm going to call it like crack txt. I'm going to put here, I'm just copying like the information that we got, the name, the host name, the challenge, the proof string, and then the whole NTLM response. Okay. Now that we have that, we are saving that on a file. So we have it here. Okay. And now we're going to use Hashcat to try to crack the password. Okay. I'm going to paste here this crazy why 2 dots after that. To be honest, I don't know exactly. That is like the I don't know if that is the correct word in English. The nomenclature, like how it's the pattern, like how this is like a build. And for Hashcat, this M5600, that is the let's say the identifier for the NTLM Hashcat. So there is like a big list. I don't know here. Okay. Depending on the hash that you want to crack with Hashcat, you will use like one identifying one hash mode or another. And because we want to NTLM, but it was this one, the version 2. Okay, this is how it looks like. So this is like how the hash is traced. You can also see here. So it's the default like pattern. So once that we have that, if you copy that and what I just like send you on the chat, Hashcat, this, and the word list. We need to provide like a word list. So normally the word list that I like to use is, Rockju. So I don't know exactly what is Rockju here now. So I'm going just to find it. Okay, now I can. So in this password list, I'm going to copy this list of password that is a Rockju, which is like this well-known super big list of common use like passwords. It's like available on Kali already. So if you're using that, you should also like have it. And then if we, okay, separator and match. That is because I put something that was not right. Let me just, okay, no, it's because I'm like calling a different name, the text file. My bad. Where is the problem here? Okay, so I just needed to put show to show me the whole like hash with the retrieved password. So if you remember, this was what we copied, but at the end is the clear text password of this guy. So this drawer stretch. You can see it at the end. So that is the password of Joseph. This one, this last one. So if you put flag and then the password inside the brackets, you are going to get the flag. But I think that this exercise is good because Joseph is not the only user that was authenticating there. You also have administrator and Barak. So you can also like try later resolving this exercise and trying to get the password of the other users. So I see that we only have 5 minutes left. So I'm not going to be able to show the last exercise, which was, let's say, big and complete, because it has like different flags and steps that you needed to do. But I mean, it's available on the platform Traboda, so you can just go there. That file is going to be there. Also, if you don't know like how to solve it, this is also, as I mentioned, something that was already on a CTF. So I think that you will be able to find the write-up online in case you are like a bit lost and don't know how to proceed with this one. But I think that with what we show today, you already have like a bit of a feeling on how Wireshark works and like how powerful it could be, and also, I mean, in a more like maybe advanced level, but this is like, for example, how malware analysis and analysts and how people studying the protocols work with. They are like going there inside the packets using like different filters, and therefore, and also with this last one, just to give you a hints up of what can you like expect there. You will be able to extract some objects. There were like some images there that you needed to extract. There was also some communication between them that you needed to find in the first place, and also some communication that was encrypted. But let's say that also the key was shared within the whole communication. So you were supposed also to decrypt the traffic using that key. So that this last exercise is like the most complete one. So if you really want to try, just like feel free. As I mentioned, I think that there should be like some write-ups on the internet in case you are like feeling a bit lost. Also, in case you, in this case, they were like sharing the private key. So Tracy, because you are asking me, so that's the reason why they were able to decrypt the traffic, the encrypted traffic. In case you have like any doubts, let me just go at the beginning. You can just on Discord, you can find me. I think that I'm just like Silvia Nerea on Discord, but on Twitter I'm like Silvia Nerea _. So feel free to send me like any messages, or if you have like any doubts. I don't know if you have, for what we have seen, like any doubts. I mean, it's a pity that we cannot like go together through the last exercise, but I think that it was like as I mentioned, like it was like an introduction session. So I hope that you already like got like the basics and how Wireshark works. I don't know if someone has like some questions, wants to make like some comments or something interesting. Thank you, Polly. Okay, so thank you very much. Yes, I will. Yeah, getting your hands dirty. That is always like the fun part. So I'm really happy that you like it. I will convert the slides to PDF, and I will share it with you, so you can have it also like for the links to the, for example, to the exploit and everything. So yeah, I hope that you find this useful, and also for the next CTF that Shakti is going to do. I don't know exactly when the dates are, maybe April, I don't know, maybe someone from the organization can tell us, but I hope that you can apply also like what you have learned today also there in the next CTF.
Okay, thank you, Sylvia. Everybody liked the session, I guess. So yeah, we had few issues with Traboda. We'll try to resolve it in our next sessions. So is anyone having any other doubts you may ask, or